So I'm here with Bob Rubino, who's the director of the F-35 program here in Washington, D.C. Now, sir, as I understand, you're a former pilot yourself.
I flew F-18s in the Navy a long time ago.
Well, something they probably didn't have back in your day is this piece of equipment right here. Can you tell me what we're looking at?
This helmet isn't anything close to what I ever flew with. It is cool. This thing has the ability to take all of the world around it and put it on the pilot's visor, and that gives the pilot the ability to look through the aircraft.
Sir, that sounds awesome. Do you mind if I try it on?
All yours.
All right.
So now you have the real helmet that pilots are flying today on the F-35, and you can see what it looks like and what they see. And you have real footage of the world around you in the infrared spectrum that gives you the ability to turn night into day.
And if I were to look down, I can basically see right through the airplane as if it's kind of like X-ray vision.
That's exactly right.
All right, sir, if you don't mind, I'd like to go over to the F-35 demonstrator and give that a try.
Let's go do it and show everybody how easy this airplane is to fly.
All right. All right, sir. So here we are inside the demonstrator. What can you tell me about the screen?
Well, so welcome to the most advanced cockpit ever designed for a fighter aircraft. And you can see this is a little bit different probably than other fighter aircraft that you've seen before. You have two touch screens. What I like to say, they're almost like two iPads that you have with you here. The other neat thing about this cockpit is it's voice activated, so you almost have like a Siri working for you.
Well, what exactly are we looking at here on this screen? It looks like a tower on the ground.
Your job is to take out the control tower of the enemy airfield. As you can see, it's showing up as a target here.
All right, well, I'm ready to put some warheads on foreheads right now, sir.
Well, I think it says in range, and I like your mentality, so feel free to push the pickle button. You'll see the internal weapon bay door open up. There goes the doors open, bombs away. Feel free to drop a second one if you really like to. There's the first bomb hitting. Impact, well done. As you're coming off the target, the guys you just bombed, there were some guys that did survive and are now radioed to the fighter aircraft that were in the area that there's somebody out here. So they're starting to look for you, and there's a couple of bad guy airplanes that you need to go take out. Now the beauty about the F-35 that the Marine Corps is going to love is it's going to give you the ability of having what we like to call first look, first shot, and first kill. And that's what stealth brings to the pilot.
All right, sir. Well, it looks like mission complete, so thank you for showing me the Corps' newest aviation technology.
It's lethal, it's survivable, you're able to execute the mission and come back and land on the L-class carrier in a very simple and easy way. Well done.
The F-35's advanced aviation technology and stealth capabilities make it the best fighter jet in the sky.
Good morning to everyone on the flight deck. Aircrew now manning for Event 1, Case 1 launch, Case 1 recovery. Temperature 76 degrees, altimeter 2966, density altitude 1787. Personnel not involved with flight house must now leave the flight deck catwalk. Time to don the complete and proper flight deck uniform. Helmets and flow coats on, gloves on, sleeves rolled down. Check your pockets for loose gear and fod. Check chocks, tie down chains, and loose gear about the decks. Ensure hot exhaust is not blowing on the aircraft, weapons, or personnel. Stand well clear of all rotors, prop arcs, jet intakes, and exhaust. Start to go aircraft. Start them up.
The spectrum of tests that we've done out here is pretty wide-ranging. You know, the sexy stuff that we get, the aircraft flying around, we did a lot of catapults, did a lot of recovery, approach work, mission flying, looking at JPALs, ICLS work at the back of the boat, did some stuff at night. But that encompasses only a little bit of what we've done out here. There's a lot of additional work that logistics test and evaluation has done that you can really only do out here at the ship, with the ship's shape, with the ship motion, with the ship's company. So we've done a lot on the hangar deck with the engine, done a lot with the aircraft, done a lot with the flying program, and it's really been multifaceted.
The big thing was the minimum end airspeed test. We did that at both mill and max power at 60,000 pounds and 55,000 pounds gross weight. So we went out and we found the no kidding minimum airspeed that you can launch the jet off at those weights in mill and max power.
We were testing down to our min plus 0 end airspeed points. We try to get to that lowest min point because we add 15 knots for the safety of our pilots and for the aircraft to safely fly away in any condition. And the reason we try to get the lowest point possible is because that's the lowest energy necessary to safely launch the aircraft.
So it's definitely a little bit different than your normal catapult launch. The biggest thing you feel is you feel the jet kind of squat underneath you, the nose pitch up. You're obviously really looking at altitude to see how low it's actually going to sink, but then the jet flies away and it's a non-event.
We did a lot of cleanup, stuff that we weren't able to finish, so we opened up the crosswind envelope, so now you have a bigger range of winds at which you can launch the airplane.
There's not a lot of times that the aircraft carrier will get into 15-knot crosswinds. They really manage their winds well. The captain of the ship is very conscious and talks to the sailors regularly about this is what our job is, to manage the winds, to manage the sea space, to recover aircraft. But there are times when you're in an operational environment where you may be constrained by the sea space that you have, other traffic, and in that case you may have to accept greater crosswinds. This time we got out to 15 knots both on the bow and on the waist catapults. And had good results for the aircraft launching and flying away in all the crosswinds that we looked at.
I did have the opportunity to do the Gen 2 night test last time around, and this time I flew the Gen 3 helmet. So the primary differences are the alignment quality of the helmet was a lot better, so that means the pitch ladder and its representation of the real world matched better. It also had better image quality, better night vision camera, and overall better display of the symbology. So a lot of our problems that we saw in the Gen 2 helmet, we didn't really see as much in the Gen 3. So it was a great opportunity to see how the technology's improved from the one generation to the next one, and what we can give the fleet once we finally figure out the final solution.
JPAL is a Joint Precision Aircraft Landing System, and it's basically just a tool, an instrument tool that we're going to use to do precision landings at the ship. It's actually got a really nice feature that none of our other landing aids have. It's data linked the final bearing of the ship, and that displays on our tactical situation display at all times when you have it up. So it's kind of nice. It gives you a situational awareness, not only where the ship is at, but where it's pointed, and where you need to go to line up with centerline for landing. The next version of the software will have the full precision landing capability. That's what we'll test at DP3. However, the Catbird does have that software in it already. So we actually have the Catbird out here flying approaches to the ship. So you have a 737 aircraft flying approaches coming down on final to the carrier and then waving it off, obviously prior to touchdown. But they were testing that precision landing capability in the Catbird.
We didn't leave anything on the table. We accomplished everything we set out to do. We performed. It's a lot like what we've come to expect as our standard. The teams work well, efficiently, almost autonomously.
It's not what the aircraft do that makes you proud anymore. It's how the team works. It's how the team adapts and overcomes. It's neat to watch the aircraft do what they do. You know, it's watching the end speed and the aircraft sink off the bow was always going to be a memorable thing. But what is more memorable than that is watching the team make it happen, watching the team work together, support each other to put that pilot in a dangerous situation, but to do it smartly and with the proper mitigation, so if something goes wrong, we know we're not going to hurt somebody. And that to me is the special nature of all of this work, is the teaming, the people, and watching them overcome and adapt.
The Air Force fighter jet, the F-35A, is advancing toward combat readiness. The first F-35A jets will likely be considered operational by the end of this year. The first model was rolled out back in 2006, and through various tests and changes, it has transformed into the fifth-generation aircraft it is today. The past 10 years have been a long journey for the aircraft, and not without controversy. In February, issues were found within the computer system of the jet that gave the F-35A media attention.
There's been some other talk in the news just about the computer system. Edwards ran into some kinks, as would be expected from a test squadron, so they had some issues in getting all the test bugs worked out.
The stuff that the test guys found back in February was great, because they turned that around and they loaded us with new software. So we're with a really stable software load right now. I'm ready to take that with my guys to combat as soon as we're called upon.
Over the years, the F-35 has drawn awareness for its cost and timeline delays. Those close to the aircraft say there is a reason this jet is an investment and has taken so long to perfect.
The jet and the platform, the avionics that it has, is a game changer for what we can do.
This game changer is a multi-role aircraft with the capability to fight in every kind of conflict.
The U.S. has been fighting a lot of wars against Afghanistan and Iraq where there's no air threat. However, this aircraft is ready not only for the war in Afghanistan and Iraq, but also the next war, the future war that might be against a near-peer adversary that would actually launch aircraft against us.
The F-35A is designed to replace older military aircraft down the road, especially because of its technology. It is crucial for the military to stay up to date or preferably ahead of advances in warfare technology. The F-35 does that in many ways.
The F-35 is a totally new platform built from the ground up, and it has the stealth capability as well as the avionics capability to be able to see the enemy and kill the enemy well before they even see us or know that we're there.
And it's really amazing to come out of a debrief and have the Red Air say, yeah, we never saw you the whole time we were flying.
The advanced technology also gives the pilots an edge while flying. The helmet they wear is a breakthrough of its own.
It's got a display visor, so I've got the display visor here I can pull down, and this thing, it'll project images through the cord cable to give me a whole lot of awareness. It can display night vision images and also images from cameras around the jet, so I can literally look through the bottom of the aircraft and see the ground.
For 2 weeks this past June, 7 F-35As from the 34th Fighter and Aircraft Maintenance Unit squadrons out of Hill Air Force Base traveled to Mountain Home Air Force Base to participate in a mock deployment exercise, flying alongside the F-15E Strike Eagles.
So that's what we're doing here for these 2 weeks, is we're flying repetition and practicing our tactics that the pilots are executing so that we can get good and ready to say that we're ready to go on our first combat mission.
These aircraft are part of a group of 12 that will be the first ever F-35s to be sent to a combat zone.
If and when the U.S., the President, sends us downrange to fight, this is the aircraft and the equipment that's going to go with us.
It is not often that a new aircraft is unveiled, and the F-35 is a historic jet that combines technology and air combat in a way that has never been done before.
It's absolutely amazing. You know, we're kind of setting history here. We're bringing a new aircraft online. You know, it's humbling to be a part of that. A lot of people focus on the jet, which is super awesome technology, but it's really the people that make it work. Without the airmen, the support and the maintenance and the pilots, none of this would happen.
And once the jet passes IOC, the work doesn't end there.
We're going to focus over the next year on still building our personnel and our forces up and continuing to improve our training. One of our major milestones after IOC will be going to our first red flag.
An opportunity for this team to showcase its game changer.
Rolls-Royce has a pitch for the U.S. Air Force. Pick the BR-725, a variant of the F-130 that powers the E-11 and C-37 aircraft, to replace the B-52's aging engines, and the company will set up a new F-130 final assembly and testing to the United States. The F-130 family of engines that we're proposing for the propulsion modernization is already a mostly US-made product, and we're going to take the final step in bringing the assembly and test of that to the US, should this program go forward, Tom Hartman, Rolls-Royce's Senior Vice President of Customer Business, said during a September 14th briefing with reporters. All things considered, the company's announcement is a little premature. The Air Force still has not decided whether to pursue a program of record for replacing the Pratt & Whitney TF-33, P-3103 engines, 8 of which are used to power one Boeing B-52 Stratofortress. However, industry remains hopeful that a program will move forward. Rolls-Royce is the first engine manufacturer to announce its offering for B-52 engine modernization. However, media had speculated that it would likely choose one of the engines in its BR-700 family, which is called F-130 in military parlance. The UK-based company has not decided where it would move F-130 assembly, but Hartman denied that the America First policies of President Donald Trump played into the decision. "We have invested heavily in America over the last 10 years, he said. In fact, recently here at the Indianapolis site we put in $600 million to modernize our facilities, but we have people in 27 states and are looking at all possible and sensible options for assembly and test of the engine." After the briefing, a Rolls-Royce spokesman clarified that the commercial BR-700 family of engines, including the BR-725, will continue to be produced in Germany. For years, the Air Force has deliberated whether to replace the TF-33s with new propulsion systems, but those efforts were reinvigorated in January when an engine dropped from a B-52 conducting training over North Dakota. Although the Air Force has still not announced a definite root cause, officials such as General Robin Rand, head of Air Force Global Strike Command, have categorized the mishap as a catastrophic engine failure that resulted in the protected casing around the TF-33 degrading, leading to the engine detaching from the plane altogether. Hartman said he could not speculate on when the Air Force would make a decision to greenlight a program. However, he sees repeated dialogue with industry as a sign of positive momentum and expects to see further requests for information from the service. "We believe the Air Force wants to keep the B-52 affordable and relevant for a long time to come, probably another 30 years or so, through 2050, he said. "They're already investing in the aircraft. Most of the major systems except for the engines have had modernization. Weapons, radars, comms are in the process of being upgraded." The biggest barrier to replacing the TF-33 is the Air Force's crowded budget, which leaves little room for an engine modernization program, which Rand previously told Defense News could cost $5 billion to $7 billion. However, proponents of modernization have said buying new engines would save the service $10 billion if the B-52's life goes until 2050. Additionally, upgrading the Stratofortress engine would increase its range and lower fuel consumption. The Air Force has also investigated alternative financing options, such as entering into a private-public partnership with industry. Hartman said Rolls-Royce had provided the service with several different leasing options for the BR-725 engine. If a program of record is approved, Rolls-Royce will likely have to compete against the other manufacturers of military engines. Pratt & Whitney has maintained that the most cost-efficient option is to upgrade the existing TF-33 systems. General Electric has not specified what engine it could offer, but Richard Abulafia, an analyst with the Teal Group, said the TF-34 could be a formidable competitor. Hartman estimates the service could buy as many as 650 engines total.
probably only got 70K, 80K. Well, no, you have to run 3. It's not 4, 5, 7. So you need for hydro. Well, no, well, hydro 4 and 5. Then we also need to look up the torque for these leads. No. Not woods. Like I said, I actually. Nah.
Oh, good.
Alright.
I used to put it at 150.
Go ahead. Block.
Like, you know.
Yeah, I know. Well,
Really
let me know when it clicks. Alright, one more time.
Yeah, it looked like you're actually doing something, though.
Hey, this is new.
What work put around it for a picture? Oh, we're in the D.
And then,
Oh my god, I can't see a thing in these.
I know. Salt Bridge hardware. Minus.
There we go. I'm nobody apparently. I don't hear anything. I don't see anything. I don't do anything. I'm just here taking up space.
Table test, self test. Good.